Hi everybody. So this week in the discussions you were working on some proofs, and overall I'd say you did a great job. Proofs are a really hard topic often for students. We do more and more of them the higher we go in math. And geometry and pre-calculus is one place that in some of the introductory level classes sometimes we see proofs. So in here we have these trig identities that we're trying to prove. I just want to mention a few things here. And I'm going to try my best to write with this tablet here. It's new to me, and I got to look at the screen and write on the tablet, and coordination might not be that good, so bear with me here. But one thing I've mentioned in some of my comments, and you'll read, if you read through the section, we talk about how you don't want to treat a proof as an equation when you try to prove it, because if you do, you're assuming that it's already true. So for instance, I wouldn't want to take this expression, assume it's true, and multiply both sides by tangent and get secant of x minus cosine of x equals sine times tangent. Okay. Let me proceed as if I was going to keep doing this over and over until I get equality on both sides is one strategy you see people sometimes use, but I'll talk about why you don't want to do a proof this way. Let's see, let's replace secant with 1 over cosine minus cosine of x equals sine of x, and then tangent is sine over cosine. Okay. And then we could make this sine squared, but let's say we multiply everything by cosine. So cosine times this term would just be 1, and then minus cosine squared equals sine squared. If I multiply every term by cosine, I'll get sine squared here. The cosines would cancel, minus a cosine squared and a 1. And then this is a true statement by the Pythagorean identity, so I have sine squared equals sine squared. Okay. Everything on the screen, it turns out, is true. However, it is not a proof because at every single step I've assumed I already had equality, and that's what I'm trying to show. This won't be true unless the original statement is true. This won't be true unless the previous line is true. So I can't do a proof and show that something is true by assuming it's true to start with. Okay? I mean, when you do it, you get a string of statements that are all true, but you're trying to prove they're true. So this hasn't really proven the result. Okay? So don't use the statement you're trying to prove like it's an equation and work with both sides. What you need to do is pick one side, work with it, and show that it's equal to the other side. Okay, and before I do that, my next comment would be, this maybe it's just me being a little picky here. They actually do it in one of the videos. Maybe it's the difference between if you want to do a proof and you want to verify an identity. If you're trying to verify an identity, you're just trying to make sure that it really is true. But when you do a proof, you shouldn't keep writing equals, again, because if you write equals, you're assuming it's true. So for instance, if I wanted to prove this, probably the first thing I would do is use the reciprocal identities, replace everything with sines and cosines. So secant is 1, get my pen back here. Secant is 1 over a cosine, and let's see, tangent is sine over cosine. I would not write as equals sine x on this step. If you do, you really mean it with a question mark. Okay, that's, say in one of the videos, I know the guy does this, and you end when you get a statement that's true. But if you do it this way, you're asking yourself each time, are these equal? Okay. So here, let's see, what could we do? We could multiply. Well, let's get a common denominator on top. There's always also in proofs. There's a lot of ways you could go, a lot of things you could do. Actually, since I'm dividing by sine over cosine, I'll multiply by the reciprocal. Okay. So this expression is equal to my numerator. Instead of dividing by sine over cosine, we can multiply by cosine over sine. Okay. Again, what I'm saying is don't keep writing equals sine x. If you do, again, you're really asking, is this equal to sine x? Let's see, if we distributed, we would have cosine over cosine minus Oops.